All right, day one, back to solving equations. You guys probably remember how to do this, but just in case, we're going to go through it step by step. So, step one is we do PEMDAS to simplify. What does PEMDAS stand for? Very good. Parentheses, then exponents. Remember, multiplier division goes together, left to right, whichever one comes first. And last, addition or subtraction, together, whichever one comes first, from left to right. So first, we want to simplify our equation by distributing and combining your like terms. That's following the PEMDAS in order. And then we go backwards to solve, where we start at the bottom with add, subtract, and then multiply or divide. And then, of course, when you get your answer, you want to check it. Okay, so let's look at our first problem that we have. Now, typically what I tell people is start on the left side. Look at all of that. Can we do anything with that? Good. We can simplify by putting that 13y minus y together, which makes 12y. Now, can I put the 12 and the 48 together? No, because they are not alike. So then I move over to the right side. Can I do anything with the right side? No. So I've simplified the left side as much as possible, and now I've simplified the right side as much as possible. So that's where we followed our order of operations in order. Now we're going to go backwards. So we are kind of still combined in like terms because we want to look for the ones that have the variables with them. Always start with your variables first. So there's a 12y on this side and an 8y on this side. How do we get those together? Good. Subtract the 8y. Perfect. If they are on opposite sides, we want to do the opposite sign to get them together. So that's why we want to subtract. 12 minus 8 is 4. And on the right side, we just have that negative 47. Remember to keep the same sign that's in front of the number. All right, what's the next step? Minus the 48. We're still going to get those like terms together. These are called our constant terms because they don't have a variable with them. So we're going to minus 48 on both sides. Now grab those handy dandy calculators or dust those cobwebs off the brain. What's negative 47 minus 48? Negative 95 is correct. And we've got one last step to do. What would be that last step? Division. We're going to divide the 4 on both sides. Very good. Now, I highly recommend you grab out your calculator for this part, and we'll just remind ourselves of a few things about our calculator. So remember, the negative key is down there at the bottom. So negative 95 divided by 4 gives us a decimal. Now, as long as that decimal ends, you can tell me that number. So if you say negative 23.75 as your answer, that is great. But you can also make it a reduced fraction. How do we make it a reduced fraction? Good. Math, enter. Perfect. So you could say negative 95 over 4. Now, either one to me is fine. I like either answer as long as that decimal ends. Now, one other thing is, let's say if I typed in 4 over 6, it gives me a long decimal. Do I round this number? Nope. In Math 3, we like reduced fractions as much as possible. So Math, enter. Make sure you say 2/3. So only round if it tells you to round, which there's only a few sections that we will say round your answers. Most of the time, write the decimal if it ends or turn it into the fraction. Now, don't forget you can also check your work. Do you guys remember that store feature that we used back in Math 2? Let's remind you of that. So first, you type in the answer. So you can type it in as the decimal or the fraction. And then the store button is right here above the on button. Remember using that button now? And you're going to store it as X. So use the X up here beside the alpha key. So that now is stored as X, and now you type in your equation like what was back here. So I believe it was 13y, which we're just change it to an x, plus 48 minus x. That's the left side. So you type in just the left side. Now type in the right side, which was 8x minus 47. Does the left side match the right side? Yes. So that is a great way to double check, but if you don't like the store feature, you can just type it in with parentheses. Is it dead? Oh no. Okay, so store feature, great way to double check and make sure that you have the right answer. And when you're taking a test or quiz, that's kind of great to use, is to store those in if you have time, so that way you can check your work. Let's see if these batteries work now for you. Nope. Let's get you a new calculator. 5. Okay. I'm just going to give you this one, and we'll get it situated later. All right, let's look at our second problem. What do we want to do with this one? Yeah, let's distribute first. Let's get rid of those parentheses. Now, you can only distribute of what's right in front of the parentheses. So what's right in front of the parentheses? -7. Good. So we've got 3x. Now distribute that. What do you get? Plus 91? Good. Now you can continue on with that left side, or if you want to move on over to the right side, what would you do with it? Distribute the 3. So what do we get when we distribute that 3? Plus. Good. Now, we're still simplifying. Do you see something else that could be simplified? 3x minus 14x. Yep, we could go ahead and put those together. What's 3 minus 14? Good. -11x plus 91 equals -6x plus 27. Good. Combining up those like terms together, get all of that the same. Okay, so now it looks very similar to the problem that we did before, where we can't simplify the left or right anymore. We got to put the variables together first. So what are you going to do to put your variables together? You could add 6x. You could also do what? Add 11x. Does it matter which one you do? Nope. I heard the 6x first, so let's go with that. Let's add 6x to both sides. What's -11 plus 6? -5x. And then what would we do? Subtract the 91. Yep, you're right. Let's subtract that. -64. All right, and last step. Divide by the -5. 12.8. Okay, good. And it doesn't matter to me which one you say there. 12.8 is perfectly fine because that decimal place ends. If not, math enter, enter. Or if you just like the fraction, 64/5 works. How do you feel about solving equations? Is it coming back? Like Celine Dion? It's all coming back. It's all coming back to me now. I wish I could sing. Sorry for anybody who watches the video. All right, let's try another problem. Now, in Math 3, you will see a lot of different variables, so it doesn't have to be just X and Y. You might see things like capital B, like in this one. If you don't like those other variables, you can always change them to X, okay? So if you want to write it like it is, change them all to X, that's fine. I'm going to use the variable that's there just so that way we see that and get in the habit of that. Okay, what would we do to start this problem? Very good. Distribute that -6. Now remember that 7b that's at the beginning, it just stays there, kind of hangs out in the front. Distribute the negative. What do we get? Good? Good, plus 12b. You can see that a lot of people might make a mistake right there and call that a negative, but a negative times a negative makes a positive. Only in math do 2 wrongs make a right. 2 negatives make a positive. Get it? All right, then what would you do? Well, you wouldn't subtract because they're on the same side and they're both positive, so you just put them together. So let's add those together first, and then we'll get rid of that 66. So 7 and 12, since they're on the same side of the equal sign, we just put those together. So 7 plus 12 makes 19. And then to get rid of the 66, we would add it. So remember, do everything you can with those variables first because it's going to make things a little bit easier as you go through. So we end up with 19b equals 76, and last step. Divide by 19 and you get 4. Very good. And if you're doing this on your own, I would highly recommend that you double check, but we're all kind of doing this together and checking as we're going through. So when you have multiple people doing the same thing and you get the same answer, it's probably right. All right, so let's go through and figure this next one out. This one, a lot of people make little mistakes on and kind of messes up the answer. So let's see if we got this. What would you guys do first? Very good. That 6 is positive, so we get rid of it by subtracting it. And don't forget, when you subtract it, you got to keep the same sign that's with the number. So this negative is with the 5. It's got to stay with the 5. So next we would, and we get, and you should always do what with that answer? Plug it back in and double check. So remember, you can just use parentheses to plug it back in and double check, or you can use that store feature. But I wanted to show you this one. I know it was kind of a short, easy one, but I wanted to show you this to make sure you keep the sign that's with the number and make sure that you divide correctly as well. Whatever's with X goes on the bottom. I had some U tries, but I'm actually going to skip those this time. Let's just go on to our next one. We just got a few more to do, so I want to give y'all plenty of time to work that homework and ask any questions that you may have, and also to get these things signed and turned back in. That's exactly right. Anytime you see those parentheses, you want to get rid of them by distributing. Now, I know a lot of you see fractions and y'all just go, okay, I'm done. I see a fraction, I'm done. Forget that mess, I'm not doing it. But you have a tool to help you. Your handy dandy, there you go. Now remember, all fractions, you put them in parentheses. So we've got 3/2 on the outside, and we're distributing, and the first thing we're going to do is multiply that by 2. So just use that handy dandy calculator because it actually simplifies the problem for you. 3/2 times 2 is 3. And think about what you typed in. You did 3 divided by 2, then times 2. The divide by 2 and then the times 2 cancels each other out. So we get 3a, and then what's 3/2 times -1? 1.5. Is it okay to switch in the same problem from a fraction to a decimal? Sure, as long as that decimal ends. So if you like decimals better, that's fine. Make it a decimal. And then bring down everything else in the problem. Now I see a 3a and a 2a. Do I combine those together? Do I just add them up or do I subtract them? You add them up because they're on the same side. They're both on the left side together. So 3a plus 2a is 5a. Perfect. We add 1.5 to both sides. And the last thing that we need to do is what? Divide by 5. 0.9 or 9/10. Either way you want to say it is fine with me. So are we going to be scared of fractions this year? You went, yes. He was like, yes. Just shook his head back and forth. The answer there is no. We're not afraid of them fractions because we have calculator. Mm-hmm. Yes, you do. On the EOC, you can use your calculator and Desmos on every single question. And Desmos will be your best friend. Let me tell you. Best buddy. All right, we have 2 more problems that we're going to do next, and I call these our what-if problems or our special cases because there's sometimes some weird things can happen in the problem and maybe things can cancel out. So maybe if my board decides to change, let me just make sure I hit the button. Okay, I did. All right, so it's frozen for a second. Does anybody else have any other questions? Okay, there they go. All right, so go ahead and write down these next 2 questions. A lot of times if they're special cases, I'll put a little what if, bless you, or call them special cases because we do have a good amount of special cases that pop up in Math 3. Stop. You did not fail. You got a C. Almost. The first time. Yeah, key thing is making sure we get our homework done. So we'll have plenty of time to work on that soon. You can always expect your math teacher to do math on the first day. Good job. All summer? Do what? All right. Tell us what to do. What do we do? You could start that way. I always say start with the variables first, though. So what would you do if you started with variables first? Subtract the 5. What happens when we subtract the 5? 0. 0 or cancels out. I like either one of those, and that's true because this is saying that I have 5 apples, right? And you come and take all 5 of my apples. Do I have any apples left? No. So some people try to put an X right here, but would that be right? No, it cancels out and goes away. It makes 0 so it's not there. So essentially, that happens on both sides. So we're left with 2 equals negative 7. Can 2 equal negative 7? No, so our answer is no solution. And you can just write NS for no solution, or you may see in Math 3 a lot a 0 with a slash through it, and that also means no solution, no answer. But if you get out the number 0, 0 is an answer, right? You can have 0 of something. But this part is saying if you plug in any number in the world for x, it's never going to equal out on both sides. So 0 with a slash through it means no solution, no answer. If you actually get out the number 0, that is an answer. X can equal 0. All right, similarly, for our next problem, we can minus 5x, and the x's cancel again. But in this situation, we're left with, does 2 equal 2? All the time, all day long, right? 2 here, 2 here, they're the same. They're equal. So we say IMS. Does anybody remember what that stands for? Good. Infinitely many solutions. If you like a super shortcut way to write it, what symbol do you think means infinitely many solutions? Y'all are drawing it out. Yep, that infinity symbol. So if you don't want to write IMS, you can put the infinity symbol, and that means the same thing. All right, your homework for tonight. First off, make sure by Friday you get that syllabus signed and returned. You get that release form signed and returned that I gave you at the beginning. And there's an information sheet that I emailed to you. That's all due by Friday. But due tomorrow is this half-page worksheet of 13 problems. You can write on here if you need to, but don't show all your work on here. Get out a clean sheet of paper, show your work, do them like we did the problems on the board. You show sequential steps and go through and answer the questions. So showing your work is important. Now, if you have a problem like this, you don't have to write what I've put in different colors. Just what I've put in black is fine. So you don't have to do plus 1.5, plus 1.5 if you don't want to. But you're more than welcome to if you want. So show all work on a separate sheet of paper. Remember, do we have cell phones out? No. Do we put our earphones on? No, but I will take music requests and we'll play a few songs on the board while you guys are working. You got 35 minutes, so you got plenty of time. If you finish or want to self-check as you're going through, the answer key is up here on top of the box. So I would highly suggest, like, do 4 or 5 problems, come check. Do 4 or 5, come check. Oh, I forgot something. My bad. Add this to your notes. You are going to see something like this, x over 2. Does anybody know a different way of writing that? 1 over 2, and then put an x with it. Good job, Landon. Yep, x over 2 is the same thing as 1/2 x. Add that to the bottom of your notes real quick, because you're going to see that a lot in Math 3. They like to do that to put x over a number, but really they mean 1/2 times x or whatever number that is. All right, let me stop this video, and I'll be coming around to answer any questions that you may have while you're working on homework.